let's take a look at our first math problem, the problem of the day. This one is one of those things where we wonder about passwords. A password is generated by a computer using 2 letters followed by 3 digits. How many possible combinations can be made if no repetitions are allowed? Wow. A password is generated by a computer using 2 letters followed by 3 digits. How many possible combinations can be made if there are no repetitions allowed? Now that would be repetitions of numbers as well as repetition of letters. So let's think about this. What I'm going to do, I'm going to create a little block of 5 things here. 2 of these are going to be letters, all right? And I think it's an easy way to view what's going on, rather than me just throwing numbers at you here. And over here we've got kind of like a license plate. It really does. It looks sort of like a license plate, except we only put 2 blocks for letters there. We're going to have 3 digits over here. Get one more. We have 2 boxes for letters. And there we have it, all right? Now, we're talking about our good old alphabet, the good old USA English alphabet. And we have 26 characters there. So in that first block, we have 26 possibilities. Now, if I'm not going to allow a repeat, that means for any combination, let's say, for example, I pick A as my first letter. I can use any letter except for A. So I'm losing one basic thing every time I go through a different part of the letter here. So I'm going to be able to take 25 options once I set my first option for the 26 letters there. So here we go. So I'm looking at it that way. I'm looking at it from that standpoint. I hope everybody understands what I just did. Again, there's 26 letters in the alphabet. We can use anything as long as it does not match with the one we've chosen. So that's why we only have 25 options to go with each of these 26 options here. Everybody with me? Got it? Hang with me on that. We're going to talk about what that actually means. And you could write all these combinations down. It would take a long time because what's going to happen in a minute, we're going to multiply those 2 numbers together, and it does get rather hairy. It does get rather large. Now, digits. We have 0 up to 9. 0 up to 9. So we've got 10 options to put in here. Now, are we going to put the number 10 there? No. We're going to put a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 situation. And again, we cannot repeat. So forget about this last block right now. That may throw some of you a little bit. But let's think about what we did over here. As long as we put, for example, we can have 0 and 0 if we pick 0 to be there. We can't have 1 and 1. But if we pick a number for that first digit place, guess what? We've got 9 options that are going to be fine and dandy for our next one. So we'll reduce by 1. All right, so there goes the 9. And by the way, some of you are going like you're turning, what is he talking about? These are going to be options, okay? How many options do we have? Options. Options, options. Who's got the options, right? And you know what happens if we should have, let's say, for example, I pick a 1 and a 2, all right, for these 2 right here. Now I cannot put a 1 or a 2 in here, can I? So now I am down to, I'm down to 8 options. And again, that's what that has to take care of all my situations. So let's see where we are at this point. Working through here. Boy, it gets kind of crazy, doesn't it? But it's sort of like who's going to cut 1, 2, 3 on this order-wise, all right, kind of thing. So again, I want 2 different digits here, and I can't repeat myself to begin with, all right? So that takes care of these right here. So this takes care of me not repeating in the 3rd slot. So let's see, what are we going to do with that? You know, some of you are probably going, let's just go back and say, what if I had 10, 10, and 10? In other words, I were allowed to be repeating. How would I figure it out? I would say 10 times 10 times 10. Well, this time I don't have 10 times 10 times 10, but what have I got? I've got 10 times 9 times 8. So that's what I'm going to do right here. I'm going to say 10 times 9 times 8. That's going to give me all the possible combinations. It's almost like kind of you're dressing up with 3 different outfits here, say, but you've got a lot of choices for those 3 different outfits, all right? You got 10 choices for a dress, you got 10 choices for maybe a shirt, 8 choices for a slacks, that kind of thing. So you got all sorts of, and trying to put there and make one outfit out of it for male or female, whatever you want to use on that. So here, we're going to do the same old story over here. We're going to say this 26 times 25, which is going to give us all the possibilities. And you say, Ernie, those numbers are getting kind of big. You know, you're very right. Let's take a look and see how big they are. Let's go to the calculator for a minute here. Let's take 26 times 25, and I'm picking up 650. Now, if we didn't have these three numbers over here, that's how many options we have already. Just using our letters, putting them together, and avoiding repeats, all right? We're going to have 26, A, B, C, D, all the way down to Z, and then we come back and each of those we can only pair 25 letters. So that's our options here. Now, while this is spinning along, we've got all these options going on also. 10 times 9 times 8, which would give us 720. And you know what we're going to do? We're going to take now and multiply those two numbers together. This is all about multiplication. And let's see what happens. I've already got 650 logged in here, but everybody knows how I did get 720, right? That's from what you get 10 times 9 times 8. A little bit of multiplication and just toss a 0 in there once you get your 72 on there. 720. And that's what I'm going to put in here. Let's multiply it by 720. And yes, it's going to be big. We already can see that. My goodness, how big is it? A lot of options. 468, whoo, and then a few zeros to add to it, right? 468,000. Now, we start thinking about things like that. And once again, if you were allowed repeats, you would have 26 times 26, then times 10 times 10 times 10. Whoo, it would be way out there. And now you're starting to see why the lottery is so difficult to win, because each of these possibilities, that's just if you have no repeats. Let's keep it in. And let's toss in maybe, oh my goodness, what is it, 40 digits? I think they allow 40 digits. And in 4, 5, 6 places, you get the idea. It gets crazy how many options you've got for a winning number. And most of them are not going to be the right one because there's only one chance, right? So there you go. A little bit of a good password type thing.